the difference between this and that one is here I am taking only one column here which is marks, okay, and I am giving the instruction to Python ascending is equal to false, okay. So it is ascending is equal to false, you can see here, okay, and the other one is with two columns, age and marks, okay. In a data set, right, you will find columns which are complementing each other, okay, or I can say in simple language, uh, if there are a correlation, okay, correlation between two columns, okay, you will find, see, every data set cannot be unique where you can where you can say there is no correlation at all, okay, it is not possible, okay. The data set that you're gonna get emails are sex column, marks, and study hours. These three are correlated here. Okay, when we have any correlation, yes, as the age increases, the marks decreasing here, as per our data. Okay, so it could be a reverse also, right? So, and name doesn't have any it is not adding any value, okay. It's just a reference for one to these four data points, okay. Reference for these four data points, okay, reference for these four data points, okay. Or even if we have a unique name duplicated, so it just add a reference, okay. So this one is standard, right? Yeah, this one is two columns, okay, age and marks. So this is the parameter it will take. By is equal to, within square braces you have to pass this to marks and age. Option I say name. Okay. Name. Okay, right. In a real-time data, right? N will be capital, A will be capital, the first letter. Okay, so just make sure. Okay, this is just a sample we are playing around, but whatever the data we're gonna learn in the upcoming classes, right? I'm gonna download live from Kaggle, or there are a lot of data sources, but Kaggle is very fast. Okay, I'll just run this. Okay, now you see ascending is equal to false. I said V S R P N. It is going that direction, right? What if I remove this one only? What values? See, A letters you can see D I K. Okay, so you can experiment, guys. Okay, so you do it for sex, for age, for marks, for study hours. Okay, that is how you're gonna practice. Just copy this command Okay, change the proper, you need to give a variable name of proper. Okay, so for example, df underscore sorted underscore name I give. I want to do for 6 df underscore started. You can change this and 6, and then here you pass the this column name, and then you will get the results. Okay, now we'll write some more. Let me save this ds3. Okay, now if I want to see a top scorer, okay, now from this list, okay, if I say, so these, I mean, okay, sorry, head. Okay, now I have this data set. Okay, we know we have 20 rows, right? I will add 20, all 20 rows. Okay, now we have this 20 rows. Now I want to see who are all the top performer here. Generally you does that, right? I mean, when it comes to support, you just pull out the quarterly report and see who are the top closure. Who all, technicians close more tickets. Okay, so you'll pick out of, if you have 20 head count, you'll pick who are the top 5. Okay, on this quarterly, and then you can present that to management to issue some gift or bonus or whatever. Okay, so now I want to find out the top 5 here. Okay, so I'll how I will do it. I'll use the sort function. Okay, df dot, I want to use sort values. Okay, same function, sort values, and then which one I want to do? I equals marks. Okay, I want to see top 5 marks. I'll say marks, comma, I'll say ascending equals false. Okay, and then I'll say dot simple, I'll say head is equal to top 5. Okay, so I am just picking up top 5. Okay, even you can type here 5. Okay, it will give you the 5 first rows. Okay, but it will not give you the, after doing the ascending, I'll get my result here. So that is the beauty. Okay, so what is that it does is, I'll just put here top scorers. Okay, so these are the 5 people. Okay, who are the top scorer. You can see 95, 90, 92, 91, 90. See that? Okay, with your data set, with using one column, you can find out. But in Excel, I don't know how to do that. Okay? To be frank, I'm not that good in Excel. I used to search in Google. Sometimes if I don't know, okay, so generally I use pandas only. Pandas is very powerful language for data manipulation, data analysis, visualizations. Okay, so this is one. Okay, another one, I can take a scenario here. I want to see students, okay, who are scoring more than 90 marks. Okay, I want to see student marks. I can do that. Simple. Scoring more than 90. Now, where is this score? Marks say greater than 90. Okay. 93. Okay. Now I want to see who are spending less than 12 hours. Okay. But their marks is above 80. Okay. How do I go about? I'll say DF square braces. Then, okay, I want to use the bracket. Why? Because I want to use two functionality here, two validation. One is study hours and the other one is marks. Okay. So always see whenever you get these type of tricky scenario, right? This is how you have to use. Okay. Data frame. Then you will say, I'll say df square. We have what study hours, right? STU study hours. Okay, I said first study hours is less than 12 hours. Okay, and then I want to see. I will add and where is the and symbol? And okay, and two condition I'm checking. Okay, so again for the second condition you have to put in a plain bracket, and then you have to say df square braces. What is the second condition? Marks. Okay, and what is the condition? Marks is greater than 80. That is my condition, greater than 80. Okay, and then I'll close this bracket. Okay, so study hours less than 12 and greater than 80. Okay, I see empty. Okay, so this there is no one who is studying less than 20 and getting greater than 80. Okay, now if I change it to 15 hours, I think I should be getting. No. Okay, less than 15. No. Uh, Greater than 15 and marks is greater than yes. Okay. So this is one condition that is satisfying. And if you're not getting any results, right, don't think your code is wrong. Okay. What that means is the condition that you are writing here that is not satisfying there. Okay. So I'll add that also. I'll just make a copy, create a duplicate. Okay, I'll just add here less than 15. Okay, 0. Okay, and greater than, if I say less than 15 and greater than 70 marks, I think we'll get one or two entries. See, okay, and this is greater than 50 and greater than 80. Okay, and this one is greater than, I'll say greater than 15, right? And I'll add greater than 17, I think 17, and marks is greater than 89. Okay, so there are four people. Okay, those who are studying greater than 17 hours in a day, in a week. Okay, it is a weekly report, not a daily. Weekly 17 hours and the score. Okay, so you can see you can satisfy something like this. Okay, and then you have to write a final insights about what you have done with your data. Okay, since I have already written this before this one, I'll just put it again. I have to write it, means will take a lot of time. Okay, I've already written in Notepad. Okay, I'll just run this. Okay, one is final insight. Okay, we call it storytelling. Okay, when you are explaining to your leaders or team, right, you have to tell this is a storytelling. Okay, so final insight storytelling is study hours strongly influence marks. Okay, clear linear trend is there. Okay, female students studied more and score higher on average. Age has almost no relation to marks. Okay, performance depends on effort, not on age. Okay, this is how you have to write your inferences here. Okay, a few students like Meera, Sneha, Isha are top scorer due to high study hours. Okay, Meera, Sneha, and Isha. Okay, above 91 and all. Okay, and Kavya is also there. Okay. And some students like Amit Nitin show good efficiency with average study hours but high marks. Okay. There is Amit. So how many hours? 12 hours but 78. Okay. Amit and the other guy, Amit Nitin. Okay. Amit and Nitin. You can see both are studying for 12 hours. Consistent. 76. Okay. Distinction. Above 70. Distinction. Okay. No, no. Sorry. 80 is a distinction. First class. Okay, so this is how you have to write your inferences. Okay, this is very important. If you don't write, there is no point. Okay, now what I'll do is I'll take the same data set and we will do some visualization. Okay, before that, guys, any question that you want to ask, or everything is clear? Yes, no? Okay, now I'll add EDA underscore 04. Okay, so I'll just paste it here. So I don't want to do it again and again, guys. Okay. Same thing. If I write this night, will take ages for me to type in 1 hour. Okay. So now what we're going to do is we will do a visualization. Okay. I'll write the heading here. H1 PDF visualizations student data set. Okay. I'll close this H1 and then I'll change to markdown and I'll run it. Okay, so if you have a proper heading, right, once you open this notebook, you can see what is this talking about. This is sample data. Don't worry, we're going to do practice with real time. Okay, cleaning and all. This is what you're going to learn. Okay, for visualization, I need to add two more libraries. Import Cbon as SNS and matplotlib. Okay, so import matplotlib. Okay, plotlib dot py plot plot py plot as plt. Okay, I'll create a pseudonym called plt. I'll run this. Okay, so I'll take the same data set. So I'll check the data info and all basics EDA. Okay, so I have how many? 20 entries, and these are the 5, okay, which we have already seen in our previous example. Okay, now what we'll do is we'll do a distribution chart. H2, H2 distribution, not charts, plots, distribution plots. Okay, Okay, and also we call it as univariate. Univariate means single column. Okay, bivariate, two column. Okay, I'll write uni v a r I a univariate. Okay, I'll just change it to this. Okay, first thing what we'll do is we'll do a histogram. Okay. Mm, histogram. Okay, I'll just add few cells here. Okay, so what is my data here? DF variable. Okay, so this is DF where all my data is stored, all this data. Okay, now I'll run df dot head. Okay, this is my data set sample. Okay, so I'm not going to do the whatever we have learned in the previous one. Okay, I'm not going to do. I'm not going to do all this in tail sample, lib, column, body, those. Now we are going to a next phase which is called visualization. So first thing first, if I want to visualize anything, okay, you know, right, the difference between matplotlib and C1. C1 is on top of the matplotlib, okay, which makes line of codes to achieve a plotting, okay, visualization. So what is my pseudo name here for SNS dot? I'll press the tab and I'll say hist hist plot. Okay, so is a function. Okay, so here it takes a parameter. First thing is you want to do the entire data set or columns. Okay, you know histogram cannot we cannot count how many entries are here. 20 entries will show. But you can show the histogram for marks, you can show for age, you can show for study hours. Okay, so I'll take here marks first. Same thing. Okay, square bracket. Okay, and then I'll put a comma. Okay, now how many bins you want? Okay, bins is the boxes. Okay, I'll say 10 bins. Okay, bin equals 10. Okay, comma. There is one feature called KD. Okay, I'll show you the difference. If I don't put KD, what happens? Okay, true. And then color. Okay, color, what color you want? COLOR. Color equals, I will say sky blue. Okay, simple. Okay, this is the first parameter. Second parameter is title. Okay, then I'll say what is that distribution of marks. Okay, and then next is plt dot show. That's it. Okay, 3 lines, and it will create my visualization visuals. Okay, it is now doing it here. It throws some error. Okay, could be an expected argument in bin. Or do I have to give in quotes? There is a space also. Uh, okay. Rectangle dot set got an unexpected error bin. Okay. Why is that? Okay, let me just remove this and let it take the default one. Okay, I give 10. 1, 2, 3, 4, 5, 6. Okay, I should have given 6 or 5. Okay, okay. Anyway, but now you see here how my data is going. Okay, and if you see the marks here, okay, the distribution is coming like this, and again it is going at the top. Okay, 65, 70. Okay, so this is 65. This you have to see the lines, okay, not the box here. So 65, then it is going 70, and you can see here this is 75, and this is going upwards and distribution. Okay, if I add comma bin equals 4. Okay, 1 minute. I've already done this. 1 minute. SNS Seaborn Library Statistics. 1 minute. Yeah, hist plot. SNS dot hist plot. Okay. Bins is equal to 20, KD is equal to true, and PLT dot show. But here the distribution of data is more. Okay, got it. Okay, we just had 20. I got it now. Why we are getting that error? Okay, because we have 20 rows, right? So you cannot divide your data into 20 bins. So that is the reason why we are getting that message. Okay, I'll show you with a maximum data also. Okay, so this is the first one. Okay, by seeing this, what is the inference you can draw here is equal numbers of males and females. Okay, sorry, not equal. Marks are mostly between 70 to 95. Okay, by seeing this graph, I'll write it down with few uh, low scores. Okay, so this is the inference I am making here. Okay, so this I want to change it to mark dot enter. Okay, BR stands for break. Break this line to next line. Okay, something like this you'll get. Okay, so 70 to 95. Next one, we'll do a count plot. Okay, so count count plot. This is used basically for categorical data. Okay, okay. What we'll do is we have a column called sex. Okay, so we'll do the distribution for that column. Okay, so again I'll use SNS. SNS. You put dot and press tab. You will get a drop down here. First letter count plot, COUNT. Yeah, this one, count plot function. Okay, and then all will take a parameter. Okay, a field and all those things. Okay, column. So here in count plot, it will take a x equals I'll say 1 minute. Yeah, 6 column, then comma. Okay, and it will take a data equals where is all your data stored. It is stored in df data frame. Okay, and then I want to use the palette. Okay, and I'll use set2. These are all the parameters, guys. You have to uh, palette palette equals set2. Okay, and then again title. Okay, I'll just copy the title from here and this one, these two. This one I'll say uh, count of students by gender. Okay, I'll just run this and let's see the results. The passing palette without assigning hue is depreciated. Okay, some feature are depreciated here. I'll remove this one. I was using this in one of the at my work, so that's fine. Okay, we can use like this also. Okay, now you see. Okay, now what do you see here? Both are almost same. 10 out of 10. Okay, there is no difference. So what is inference you can draw here? Okay, equal number of male and female student. Male and female students. Okay, so see, just visualizing will not work out, guys. Okay, you have to see the graph and you have to bring the insight. Okay, without insight, it's utter waste doing all these things. You have to write the inference. Then only this is how you're gonna learn. Okay, that's the reason we are doing with the sample 20 rows data set. In real time, when we do this Netflix data set is very famous. Okay, and everybody loves watching movie, right? And we will when we practice this from next week, right? You will like it. You will definitely like it. The analysis and all that on those data sets. Okay, so this is done. Next one, I'll just copy this. Okay, oh, Control Z. I'll just put it here and then I'll say count plot is done, then hist plot is done, and then what we'll do is now we'll see look at the bivariate analysis. Okay, so more than one column now. Okay, so we also call this as relation plots. Relationship plots. Okay, this is bivariate analysis. Okay, now I will do H. Okay. Now what I want to do is relationship. I want to see the relationship between marks and study hours. Okay, I want to see the relationship in visualization, whether there is a relationship between marks and study hours. Okay, so scatter plot is one of the famous for relationship. Okay, how to find out how to infer from the plot? I will tell you. Okay, so scatter plot. So of what? Study. Study of marks and Marks versus, sorry, study hours versus marks. Okay. Okay. Again, we'll use the SNS library dot. I'll say scatter. Yeah, this is the one. Scatter plot. Okay, and when you take when you keep your cursor inside those braces, and when you type this tab, you'll get this drop down. Okay, what it is giving, all the parameters that we can pass within that braces. Okay, so first one is x. See, x it gave equals what I want to do, marks, sorry, study hours. I'll say study, study hours. Okay, then comma. See, scatter plot, everybody know it has a x and y axis. In x axis, which is down. Okay, what I want, study hours. Okay, on y top, what I want, marks. Then I'll say y equals to uh, marks. Okay, y equals to marks. Okay, and then data, yeah, data equals to df, data frame. Where is my data? In data frame. Okay, you have to point that. And then I have a data frame. Yeah, I think this many. Let me type this data many, and then sample data size, yeah, is size equal to 100. I'll take 100 sample, and then comma hue, hue. Okay, hue is like just like a group by. Okay, what you do in Excel. Okay, hue is equal to which column I want to take. I want to differentiate. We have gender, right? Sex, this way. Okay, and then I will use the same plots here. Okay, same, this one title and this one. I'll just copy. I'll just copy here and here. Okay, I'll just copy this one and then show. Okay, let's run this. Okay, so hue, you can see what is the hue, male and female. Okay, if I don't add this, what happens? I'll just copy it. So everything is in blue. So do you understand anything here? No, right? That is the reason I'm using hue. Okay, now here see, very beautifully it is coming. Gender, we are getting male and female, and these are the data points, and you can see who are leading, who are going toppers here, female. Okay, with the marks that they are scoring here. Okay, so this marks is above 85% to 95, they are leading the show. Okay, and gents above 80%. Okay, how many students? Up to 13 students out of 20. Okay, and this one from here to here. Okay, you can count, because since we have only 20, you can count 4, 6, 8, 10, 3, 6, 7, 8, 9, 10, equal amount. Okay, so this is one way that you can bring out the relationship. Okay, wherever you see dense, right, if all these are near to here dense, right, then we have to pick up those dense area. Okay, so what is the inference I can draw? Okay, inference I can draw from this is, I see a strong, I see a strong positive. Okay, now you see why I'm saying positive. It is going in a straight line. Okay, so it is increasing. What if it goes and comes down? Then I have to say there is a decline after some point. Okay, that is a strong uh, positive linear relation. Okay, relationship between two variables or features. Okay, column name we call it as features. Okay, it is in linear line. Okay, so and it's positive. That is what I mentioned here. Now I'll show you the box plot here. I'll just copy all these things. Okay, box plot. I will use marks by gender. Okay, okay. How to create a box plot? SNS dot. You type box and you see function called box plot. Okay, in box plot, what are the parameter it will take? It will have also have x and y. Okay, so x equals x and y I want marks. Okay, okay, marks small. Okay, otherwise if it is not matching with the column names, same case it will throw an error. Okay, marks then comma data equals df data frame. Yeah, that's it. And then I'll copy these two lines, title and show. Okay, I can say marks distribution, gender. Okay, I'll run this. Okay, now you see this is a box plot. Okay, so you have y and x. Okay, in x what we have? Gender. Okay, male and female we are seeing. Okay, now if you see the marks here, so the marks, see, this is a box plot. Okay, whatever you see here, this and this line, this is called whisker. Okay, so this whisker, any data points which are out of these whiskers, right? Then we call it as a outlier. Okay, I'll do one thing. I will add one data. Marks is there, no? So I'll do one thing. Last one, I will add 190. Okay, just for our example. Okay, I'll run this now. Okay, now you see it has changed. Now you see this circle. So there is one outlier. Okay, so whatever the data points that are there, it should fall between this whisker first, this top and lower whisker. Okay, your data point, and this black line that you see, this is a median point. Okay, statistics, see, everywhere statistics is used. If you know statistics or you want to brush up, I'm telling you, that is what they look in data science. Statistics, data. Okay, so this is your midpoint, the what do you call, average, mean. Okay, and your data is the, for male data is falling within this whisker and this whisker, which is looks good. Now here in female, one lady, she has scored 193. Okay, and that is where it is showing a data discrepancy. Okay, this is what you have to solve it. Okay, I'll just change it for now. Okay, I'll just go quickly, and again I'll run this. Okay, so the line that you see here. Okay, so now this is a 25 percentile, this is a 50 percentile, and this is 75 percentile IQR. Okay, and any data that goes this whisker and this whisker outside here, you might see lower data points also. Okay, if someone secured 10 marks, okay, it will show somewhere here. Okay, those round circles. Okay, and here also. So this is what you can analyze. Okay, yesterday we did SQR into IQR into the calculation 1.5 into 25 percentile, 50 percentile, and 75%. We are seeing whether our data points are between 25 and 50. Okay, if anything goes beyond that, those are treated as outliers. Okay, right now in my data set, I don't have any outlier. Okay, I just showed you the outlier example live. Okay, by changing one data set for marks, which I gave heavy. Okay, I mean extreme number, which is in 3 digit, which cannot be true. Okay, so our marks score, what is that, 100 out of 100, and how can it be a 193? Maybe it could be a typo error or some system error. Okay, that is what you have to go back to the uh, uh, business team and ask, I see this discrepancy, is it correct or incorrect? If they say no, these are a typo error, you can correct it or you can treat it. So you can treat it. Okay, we'll see all those things in the next session next week. Clear, guys? So far, okay. Now we will also see. Okay, violin. So we have something called violin plot. Violin plots. Okay. Here I'll take study hours by gender. Okay, so again, how to write SNS dot VI, yeah, here we go. Here it is, and then the same thing. Okay, what are the parameter it will take? X equals, I'll say gender I'm using. So column X, Y equals study 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 underscore uh, URS hours. Okay, so this is the second column I'm taking, and again you have to point your data. Okay, so where is your data? In DF, that is the variable where we have all our data. Okay, yeah, I think that's pretty much, and I will use the same, these two default. Okay, so this one I'll just slightly change the 1 minute. Okay, so study hours distribution by gender. Okay, I'll run this. See, okay, now you have to see this. This is a male. Okay, if you see this part, right? If it is very flat, right, and these data points that you see, okay, using a violin plot also you can find out the outliers. Okay, so this white dot that you see, this is your midpoint for male, and this is for female. Okay, these are your data points that are within this violin shape. Okay, generally we don't use it, but instead of box plot you can use this also. Okay, same purpose. So, and you can see here, out of these two, which one is bulged here? Female one, right? So little bulge, right? So I can write my inference here. What is inference I can draw from this chart? Uh, Female student, okay, female students spend more time for study hours. Okay, okay, you can see this little bulge and this is little curve. Okay, this is what you have to draw the inference. Okay, time they are spending more, female. Okay, you see from here. Okay, so this point, okay, and this point. Okay, so if you take on an average somewhere here, so 15 and above female students are spending more hours on studies. Okay, you can do the same with uh, study hours and marks also. Okay, you just create a duplicate of this, and then this is what you have to do, break and learn. Okay, now we'll do multiple relation. Okay, pair plot will do. Pair plot. I think I'll just copy this. Scatter plot is there and pair plots are there. Okay, pair plot, and we called it this multiple relationship. Multiple relationship. Okay, so how do we start? SNS dot uh, pair. I'll say, right, yeah, pair plot, and same thing. Okay, it's a function. Now you have to do all those things. Okay, here it will take a slightly different parameter. Okay, when I said a relationship means what? Multiple means multiple columns. Okay, so whatever the columns we have in our data set, so I'll take all those things. Okay, whenever you're using multiple you have to use additional two square braces like this inside. If it is one, you can use one brace. Okay, if it is multiple you have to use another square braces, and here I'll say age, comma, what are the marks? Yeah, marks also is there, so I'll say marks, comma, then I have study hours, study hours, and we have gender, right? I'll take that as sex. Okay, and after this I'll put a comma. Here you have to give the uh, data. Okay, date, no, data is not required because we are already giving df, so data everything is coming here. Okay, so this one df we are already giving, so it is coming, so we no need to give data is equal to df. Okay, this will take another parameter called hue, hue is equal to, again I want that categorical one. Okay, sex, and yeah, that's it. Okay, next line. Next line I'll say plt dot show. Okay, see, pair plot, beautifully it has come. Okay, hue, you can see color code blue for male, this amber or orange female. Okay, now you see age. Okay, so you see age and what is the relation, age and marks and study hours. Okay, so first one is age. Okay, so age, marks. Okay, and this one you can see marks, relationship between female and male. Okay, so blue is female, male, and this is female. Okay, now you see age group, who are the highest age group here, female. Okay, male is maximum from 19 years to 23. Okay, that is what you can draw the inference by seeing the pair plots. Okay, and marks you can see blue, and who is leading here, females. Okay, 95%. Okay, and this one is studiers, who is spending more time, you see a dense here, females. Okay, and you see here also marks, also females are getting more. Okay, this is age, this is marks, and this is study hours. Okay, so three different we are picking up: marks, age, and study hours. And you compare it by, like, it's just like a group by, guys. Okay, in group by we get in Excel like in a text, right? But here we are getting a pair plots. Okay, that's the beauty of this pair plot. Okay, so I'll just copy. Okay, bar plot. Okay, same thing. Okay, so same thing we did hist plot, right? So this is a bar plot. You can see here the color code, age. Okay, so age, you see age versus marks. Okay, as the age is lower here, 20 years, is scoring above 80 and above. Okay, 21. As the age increases, the marks decreases. Okay, the CI parameter depreciated, none. Okay, CI I'll remove. This is not U is depreciated, will be removed in version. Okay, so this is not a error, something has depreciated, but we are adding here, right? So that is the reason it is not coming up. DF, age, marks, title. Okay, so this is a bar plot. Okay, uh, okay, this is done bar plot. Then age and marks. Okay, so here if you see age and marks, both are numerical data, right? Okay, now we'll do the same thing. I'll just copy this instead of typing again. I'll change again. I'll use the bar plot here. X is instead of age, I'll use X df and average mark by age. Instead of age, I'll say gender. Okay. So this is this just a future warning, guys. If you don't want this, you can do that. Okay. There is a library for it. 1 minute. Uh, This is the one. Okay. Import warning. This column you have to take. Okay. These two. I forgot this. Okay. Now you are seeing this red line, right? If you don't want this, you have to mention this at the very top. When you get any code from internet trend, you will see lot of libraries here. Okay. Did I not copy these two? Okay. I'll just run it once. Done. Okay. So if I go down and if I run this, okay, now I'm not getting, see, this is how you can use those libraries. Okay, import warnings, and then you can say the parameter like they were saying warning dot filter warning is equal to ignore. Okay, it will suppress all warnings. That's it. Okay, so this one also, if I run this, you will not see that. Yeah, now it looks good. Okay, so this is one. Mm, there is one more called swarm plot. Okay, so this is the last one for this week. SWA swarm plot. Okay, so we'll say marks what says study hours. Okay, so I'll say SNS dot SW, yeah, swarm plot. Okay, swarm plot, and then it will take x equals to gender, comma, then we have by equals marks. Okay, and here I'm not mentioning any df here, so I'll say data equals df. Okay, that's it. And then I will take these two, title and show. Okay, just copy paste, and here you can say marks spread by gender. Okay, so this is swarm plot. Okay, this is how it looks. But in real time, right, when you do big data sets and all, right, you will spend a lot of time on your this thing. Okay, and just write down the analysis here, final, which I have copied in a notepad. Okay, so you can refer this later. Okay, final visual insights is mark distribution. Most students perform well, 70 to 95. Gender balance, equal male, female. Okay, and female shows higher performance. Study versus marks. Strong positive relation is more study hours means higher marks. Okay, female study more, thus score better. Age doesn't impact much. Efforts, study hours drives result. Okay, this is how you have to write your inference. Okay, correlation heat map. Okay, correlation heat map. Marks, study hours are highly correlated. Okay. Oh, did I do the correlation? No, right? 1 minute. I'll do it just 5 minutes. SNS dot uh, heat map. Okay, we called it as heat map. Okay, and then here it is slightly different. You have to say df dot corr correlation. Okay, corr, and it's a function. So you have to mention you pick only the numeric value. Okay, numeric, numeric underscore, numeric underscore only is equals true. Okay, this is a first parameter. Uh, second, and annotation equals to true. And it is equal to true, and then you have C map. Okay, C map is the color code. Okay, color for maps. Okay, what is the color you want to do? I want to see cool worms is there one famous. Okay, you'll see shortly now. Worm. Okay, and when you get the heat map in boxes, right, there's a width also, one parameter called uh, 1 minute. I don't know what is that line width. See, oh, second one. Okay, line width equals I can say 0.5. Okay, not more than that. And then, as usual, the title and show. These two command you have to paste it here, and I can say here correlation heat map. Okay, I'll run this and then I'll show. See now, you see this width, this white line. Okay, this is the line width. Okay, if I give one, okay, this is one. You see the it has increased the line width. Okay, like that you can make changes. Okay, 0.5 is what I use generally. It looks good. Okay, cool warm is this is a color. Okay, now here how do you interpret the heat map here? Okay, you see here the scale. Okay, when you see here the lighter and it starts from 0 and this is minus and this is negative and this is positive. Okay, so the more the darker there is a relationship. Now here you see age and marks is there. Okay, marks and age is there. Okay, now you see there is a negative correlation here, marks and age. Okay, but if you see study hours and marks, there is a high correlation here. Okay, high correlation is there. Okay, study hours, if the study hours are more and marks also is zero point 0.9, which is there is a correlation, strong correlation. That is the reason I have written marks study hours are highly correlated, 9.9. Okay, age and marks, there is no correlation. We have seen, right, as age increases the marks is decreasing. That is the reason it is going in negative. Okay, and this one study hours and age, there is one relation. Okay, so this is the we call it as a heat map. Okay, so easily you can see your correlation data here, and then you can do the inference. Okay, so this is EDA 04. Okay, let me first send it, and okay, I've shared it. Please guys practice it with all these things. Okay, and now what I want to give you is some homework. Okay, so what I'll do is I will share tomorrow. Okay, not today, tomorrow, 4 different data set. I'll name those. Okay, for whom I'm giving. Okay, so one is for Saheb, one is for Kiran, one is for Sai, another one Rupa and Vishan. Okay, so I will run a data set, sample data set, and I'll share with the name according, and you have to do the ED. Okay, all steps, whatever you have learned. Okay, I want to see that on Monday. So Monday, you guys have to share your screen and you have to explain. Okay, the inference. Okay, but I'll not give this data set. I'll pick up something else. I'll generate now. I'll write a code instead of mark study. I'll give some different data set for different people. Okay, You can Google it, guys. Okay, that's fine. But see, whatever you have learned, right, just go back to your the Jupyter notebook and refer. It will be very quick. Okay, these are the things that everybody does in any company, data scientist. Okay, so they do all these things and they'll bring out all those insights. This is just the basics. Okay, then again we have intermediate like probability, statistics, and all that. Okay, weather forecast data is there, whether it will rain this year heavily or mild or no rain. Okay, you have to predict from 10 years data. Okay, so this will give you a good idea about how to play with your data set. Okay, so guys, that's all for today. I'll share the data and I'll name. Okay, please practice on weekend. Okay, and I want to see how much you guys are able to do. Okay, even if you're doing mistakes, that's fine. I will correct it with a live. So Monday will be completely uh, uh, practice session for you guys, and I want to see the data. Okay. Chalo guys, we'll close this session. I think we are on top of the hour.